Hello everyone. We have a question which says that four coplanar forces act at a point. What are coplanar forces? Coplanar forces are the forces which act at a single point. If you just look at the diagram, we have F Newton force, 20 Newton, 30 Newton and 40 Newton force. All the forces are acting at this particular point. Therefore, all these four forces are called coplanar because they are acting at a single point. The magnitudes of the forces are 20 Newton, 30 Newton, 40 Newton and F Newton. The directions of the forces are shown in the diagram. Directions means the angle 60 degree, alpha, theta degree and beta degree, where sine alpha is equal to 0.28 and sine beta is equal to 0.6. The question says that given that the forces are in equilibrium, find F and theta. So the condition that they have given us is the condition of equilibrium, and equilibrium means the opposite forces are equal. And when I say the opposite forces are equal, that means the opposite horizontal forces are equal as well as the opposite vertical forces are equal. So basically we have to split the horizontal components as well as the vertical component in order to find the value of this F and theta. Before starting with the question, let us first understand what the components are, because I have seen that students mostly have a misconception that the horizontal component is always a cos component of this particular force. It is not like that. For example, this is an angle that you are being considered. That means if this angle is over here, the side next to that angle will be the cos component of that particular force, and the opposite side will be a sine component of that particular force. But for example, if the angle is over here and that is given in the diagram, then the side next to that angle would be a cos component of this particular force and the opposite would be a sine component of that force. So it is not necessary that the horizontal component is always a cos component. It depends upon the angle. So what I have done is that I have split up the horizontal and the vertical components of these four forces. If you just look at the 20 Newton force, which is making an angle 60 degree, so this angle 60 degree is with the x-axis. The horizontal component would be 20 cos 60 because 20 is over here, and the vertical would be 20 sine 60. Similarly, 30 Newton is the force which is making an angle alpha with the x-axis, so the horizontal component would be 30 cos alpha and the vertical component would be 30 sine alpha pointing downward. Similarly, F is the force making an angle theta with the x-axis, so the horizontal component would be F cos theta and the vertical would be F sine theta. And finally, the 40 Newton force is making an angle beta with the x-axis, therefore the horizontal component would be 40 cos beta and the vertical component would be 40 sine beta pointing downward. Now because we have all the components, and we can see that when we have splitted them up into components, we can see that we have the sine of a particular angle and a cos of a particular angle. For sine 60 and cos 60, definitely we can find the value, but definitely for sine alpha, cos beta, sine beta, definitely they have given us something in the form of where sine alpha is 0.28 and sine beta is 0.6, but they have just given us sine alpha and sine beta. They have not given us cos alpha and cos beta. So based on this sine alpha 0.28 and sine beta 0.6, we will find the value of cos alpha. If we just look at the working, we can see that sine alpha is 0.28 and this 0.28 can be written as 28 upon 100 due to the two decimal places, and this 28 upon 100 when simplified would be 7 upon 25. And we know the relation that sine is equal to opposite upon hypotenuse. Opposite is over here, so opposite is basically representing 7, hypotenuse is 25. By using the Pythagoras theorem, we can easily find the third side, which is the adjacent, and by simplifying this and using the Pythagoras theorem, we can see we have the 24 as the third side, and we know the relation of cos, and that would be adjacent upon hypotenuse. So adjacent is 24 upon hypotenuse 25, so 24 upon 25 when converted to decimal would be 0.6. That means based on this sine alpha 0.28, and by using the Pythagoras theorem, we have found the value of cos alpha. The same process we are going to do with the sine beta as well. It is 0.6, just one decimal place. So 6 upon 10, simplify 3 upon 5, and we know that sine is opposite upon hypotenuse. By using the right angle triangle, this 3 is opposite, 5 is hypotenuse, and by using the Pythagoras theorem of using 5 and 3, we can find the third side, which is adjacent, and that is 4. And now finally we can say that cos beta is equals to adjacent upon hypotenuse, which is 4 upon 5, and 4 upon 5 is 0.28. That means from sine alpha and sine beta, we have found cos alpha and cos beta. Now we have all the values, and now we could use the condition of equilibrium and work out the horizontal forces as well as the vertical forces. If we just look at the horizontal forces and look at the diagram, we can see that we have two horizontal forces pointing to the left and two horizontal forces pointing to the right, because the condition is an equilibrium. So the sum of these two would be equal to the sum of these two. That means f cos alpha plus 40 cos beta, f cos alpha plus 40 cos beta would be equal to 20 cos 60 and 30 cos alpha over here. By rearranging it and placing the value of this sine alpha, cos alpha, sine beta, cos beta wherever it is required, as we can see f cos theta, theta is an angle that have to be found, and f is also the force that has to be found. 40 cos beta, we have found 0.28, we have kept it over here. 20 cos 60 can be worked out, and 30 cos alpha and cos alpha is over here 0.96. so we could simplify this, and that would be equal to 6.8, and the first equation from the horizontal forces would be f cos theta is equals to 6.8. The same strategy can be applied working with vertical forces. If we just look at the diagram, we can see that there are two vertical forces which are pointing upward and two vertical forces which are pointing downward, because the condition is equilibrium. So the sum of these two would be equal to the sum of these two. So f sine theta plus 20 sine 60, f sine theta plus 20 sine 60 would be equal to 40 sine beta over here plus 30 sine alpha, and we know the value of sine beta, sine alpha, we know the values, it was given in the question. Just place them, simplify them, and after simplification we can say that f sine theta is equals to 15.1. Now we have two equations, and definitely we have two different methods to solve. If we just go through the first method, we can say that dividing the equation 2 by 1, the equation 2 is f sine theta, and dividing that by 1, that means f sine theta divided by f cos theta over here would be equal to 15.1 divided by 6.8. So dividing equation 2 by 1, and after cancelling this, f sine upon cos would be tan, 15.1 divided by 6.8 would be 2.22, taking the tan inverse of this 2.22, and we have found the angle theta, which was the requirement of the question. Now placing this value of theta in any of the equation, whether equation 1 or whether equation 2, get the value of f. If we take the first equation, f cos theta is equals to 6.8, and place the value of this theta 65.8 over here. So cos 65.8 when divided by 6.8, definitely the result would be the value of f, which is 16.6. This is one of the easiest method. The second method is also very easy, and that is squaring and adding equation 1 and 2. So we simply square them and then add them. We have f cos theta, f sin theta. So first square them and then add them, and values also 6.8 and 15.1, square them and add them. After simplify, we have 274.25, and after simplifying the bracket, it would be f square cos square theta plus f square sin square theta. Taking f square as common, we have in the bracket cos square theta plus sin square theta, which is an identity, equal to 1, and therefore f square would be equal to 274.25. Taking the square root so that we could find the value of f, and definitely it would be 16.6. that was same that we found from method 1. Now placing this value of f in any of the equation, whether equation 1 or 2, if you take equation 1, f cos theta is equals to 6.8, place the value of f over here, divide below 6.8, get the answer, then take the cos inverse of this answer. The angle would be the same 65.8 that we got from the first method. Both the methods are super easy. You just have to work any one method to get your result.